All right, continuing chapter 4, we're going to talk more about functions. Two different things today. We're going to talk about dependent and independent variables, and then also function notation here at the end. So let's first of all talk about how we can model a situation with an equation like this. This is called a function. It's a machine that tells us how much money a person's going to make for babysitting at $8 an hour. And you can see that you can plug in different x values. If you plug in 0 hours worked, 8 times 0 equals $0. Okay. If you plug in 1 hour of work, how much money do you make? Well, you make $8. So we worked 1 hour, we make $8. We worked 2 hours, you can see, you plug in 2 there, you're going to get 2 times 8, which is 16. So y equals 16. Remember, y equals, in this problem, dollars, and x was hours worked. And you can continue to do this further and further. Okay. Now, building off of the last section, we could talk about the domain here. Remember, the domain is all the x values, and range is all the y values. In this problem, the domain is not all real numbers. We really can't plug everything into this, even though it seems like we could. We can only plug positives in, or 0 and higher, because it only makes sense to work more than or equal to 0. So that's called the domain. Here is more than or equal to 0. And then the range of money you could make, the range would be anything bigger or equal to $0. And you've seen this before. The input, the number that you get to choose, is called the independent variable. It's independent of anything else. You get to pick it. It happens. All right. You just pick it, and it causes something else to happen. So let me write the word cause here. Input causes the output to happen. So the output, therefore, we say is dependent on the input. The output is dependent on the input. So the output is the dependent variable. Now, on our previous example, we were inputting hours, and we were outputting the dependent variable, which was y, which was dollars. So on your homework, you're going to have to figure out which one's the independent, which one's the dependent. In the winter, more electricity is used when the temperature goes down, but less is used when the temperature goes up. So it sounds like what you want to do is create a sentence. Something causes something else is one way to come up with it. Now, electricity does not cause the temperature to change. So temperature affects electricity use. So temperature is the independent variable causing the dependent variable to happen. Here's another simple example. The cost of a shipping package is based on its weight. So what causes what? Does the weight cause the cost, or does the cost cause the weight? Well, the weight causes the cost. So therefore, weight is the independent, cost is the dependent. Very simple. Now, the example we've been looking at has been y equals 8x. That's called a function. Think of it as a machine, a little calculator that tells you how much money you make when you're babysitting and you get paid $8 an hour. This is a little machine. Well, it's called a function, and we say that y depends on x, right? Y depends on x. The amount of money we make depends on how much we work. So we say y is a function of x. And there's this fancy notation called function notation. Okay? We say that the variable y is actually a function, and it depends on x. So the way this is read, this is called f of x, and I spelled f out phonetically there. F of x. F of x. We have a function, and it's made up of x's. This is not f times x. Let me repeat that. This is not f times x. F is not a variable. F is a notation. This is a way of saying that we have a function here, 8 times the input, and the input is an x. Okay, this is function notation. Let's take a moment and figure out what this screen says. Don't look down below just yet. Up here I have defined or given you two machines. This one's called f of x. And what it does is it takes 3 times the input and then adds 1, because we have to follow order of operations, of course. So machine F takes 3 times the input and then adds 1. Now, in blue over here, we have a different machine. Think of it as a different computer, a different little calculator machine, and we're going to call it G. We're going to give it a different name. And that's okay. We can give it any name we want. We're going to call this machine G. And it takes x as input. That's why this is called G of x. And what does the G machine do? Well, the G machine squares the input. The G machine squares the input. So let's come over here. This is pronounced f of 2. So that is asking you to substitute 2 into the machine. Here's the f machine. And you need to put the number 2 into it. So that's 6 plus 1, which is 7. So the answer is f of 2 equals 7. f of 2 equals 7. Now let's go to f of negative 1. f of negative 1 means that you need to take the machine, oops, need my pen, take the machine, which is 3 times the input plus 1, and put negative 1 into it. So we have to follow order of operations. 3 times negative 1 is negative 3. Negative 3 plus 1 is negative 2. So that's the answer to f of negative 1 is negative 2. Now let's come over here and do a couple of the G problems. G of 4. Now, we don't go over here because this is the F machine. We've got to go to the G machine, which is the G machine. Remember, it squares the input. So F or G of 4 is inputting the number 4. So we have to square 4, which is 16. So the answer to G of 4 is 16. Now let's look at G of 3. G of 3 means to square the input, which is 3. 3 squared is 9. So we say G of 3 is 9. G of negative 2, let's be very careful on that one. Negative 2 squared is going to be negative 2 times negative 2, which is positive 4. Positive 4. And then G of negative 3 is going to be positive 9. Negative 3 times itself. Let's come back over here to the F machine. We're going to input 4 here. 3 times 4 is 12. 12 plus 1 is 13. You can do it in your head. I don't mind, just so you do it right and follow order of operations. F of 0 means plug 0 in for x, multiply by 3, and then add 1. Of course, that's 0 plus 1, which is not 0. It's actually 1. So this is called function notation. Notice this is not f times 2. This is a notation that's telling you to run 2 through this machine here. It's called function notation. We're going to use it all the time in algebra, so you need to get used to seeing this.
Made with Doodlecast Pro.